Good morning.
Good morning.
Morning.
And did you all enjoy your extra long weekend? Yes? Did anyone do anything amazing? Had an extra day for amazing?
Well, depending. We did go get like new mattresses for me and all my sisters, but then we stayed up late putting them in. So.
Well, I guess, if you've been sleeping on the ground, a mattress, that's an amazing thing, right? So that's awesome. Anybody else?
I went to an NAU volleyball game. That was pretty fun.
So was it amazing?
Yes, it was. I'd highly suggest it.
Isn't it cool how just that next level? I'm not sure I was really prepared for college level volleyball when I saw it. It's just almost a completely different game. Wouldn't you agree?
Yeah, it's super fast paced.
Super
Crazy.
fast, so much power, right?
Yeah.
And it really, I guess if, I guess the first time I went to an NFL game or NBA game, I was, but even then, I think the jump from college to pros, that jump from high school volleyball to college volleyball is just amazing. It's so eye-opening. Anyway, I'm glad you had a chance to do that. Anybody else?
I went on a double date.
Oh yeah? Well, that's pretty good. So was the date amazing, or the fact that you were able to go amazing, or?
It was a good date.
Was he a good kisser? No, don't answer that. Don't answer that. I don't. There's certain details I don't want to know about because it could be, we could be breaking somebody's heart that's somewhere else. So we don't want to get too much. So anyway, well, that's good. Anybody else? What was that?
I went to Catalina Island.
Oh, nice. So that's pretty cool. So you were on a cruise?
Yeah.
So was that your first cruise?
Yeah. It was my first time out of state, too.
Nice. I think cruises are definitely amazing. And Catalina is a great place. I can't imagine going there in the 50s when the Dodgers used to play games there, to have their practice facility. That would have been pretty amazing. So anyway, if you haven't been...
Dodgers.
What?
I said it wrong because it was the Dodgers.
Oh, you don't like the Dodgers?
You're talking to a Diamondbacks fan. What are you talking about?
I thought your dad liked both the Dodgers and the Diamondbacks.
We don't need to speak about that man here. We don't need to. He's a Dodgers fan now, and I don't like it.
Anyway, well, okay. While we're on the subject of sports, let me just say, if you didn't watch Monday Night Football last night, that was an incredible game. And I don't even like those two teams all that much, but that was about one of the best games I've seen in a long time. So sometimes, greatness you can appreciate, whether you like the team or not. But anyway, all right, well, let's see. We got everybody in Joseph City. Are we missing anybody in Holbrook? Looks like everybody's there.
Braylon and Serena.
Braylon and Serena. You guys do a good job of covering for them when they're not there. Thank you for letting me know that. Braylon and Serena. Okay. All right. Well, whoops. I just took attendance for yesterday. So we'll have to figure that out. I'll fix it. Okay, so tomorrow the quizzes are that we're going to do are 3.5, 3.6, and 3.7. So the last three quizzes in Chapter 3. We are not doing the Chapter 3 test until next week. Okay? So the test will be a week from tomorrow. So tomorrow is just the last 3 quizzes. Okay? Any questions on that?
This is a few weeks early, but what days of school does NPC have off for Thanksgiving? Do you know that?
Thanksgiving Day and Black Friday. So Thursday and Friday only. The Wednesday before, which you'd think you might have to drive to Kingman or something to see family. No, you don't get that day off. So no, Wednesday. So I have all my classes that meet on Wednesday. So I'm planning on doing quizzes on that Wednesday. So we might. I was just thinking this morning, actually, on the drive over, that I might have a plan for people that might be going out of town on Wednesday. So we'll figure that out. I'll mull this plan over in my brain, but I'm trying to make it so that we still make progress in the class without maybe. Anyway, well, I'll let you know next week what I'm going to do the day before Thanksgiving. Okay. All right. So anything else before we get started today? Okay. So we have, so today we're going to finish 4.1 and hopefully start in on 4.2. You only have the guided notes through 4.3. So I've got to get the rest of those to you before next week. Let's see, what else? Well, let's just go ahead and get started. Hopefully the board's going to work today. We are on part 3, which is the back side of the page. So we'll pick it up from there. Okay, so this part is on solving polynomial inequalities. So we've done inequalities like x is greater than 3 or something, but we've never done inequality, and you might never have done like x squared plus 3x plus 7 is greater than 3. Okay, you might never have solved something like that. So if I'm gonna start off. Normally, I teach you how to do it by hand first, and then the calculator. This time, I'm going to teach the calculator method first, because the way that we do it by hand is actually so important that you have to learn how to do it anyway. So, but I'm going to do the calculator method first. So if we have an accurate graph of the function, either by hand or by the calculator, solving a polynomial inequality is very straightforward. Simply read where the function is above or below the x-axis. Okay? And that will be your answer. So what I'd like you to do is, for practice 3, type that into your calculator. Okay? So type this into the calculator. Now, don't worry about the greater than or equal to 0. Just do y equals this function.
Do we do all 3 in separate ones?
All in the y1. All in the y1. Here, so it's all going to be for the y1. You just have parentheses in there. Okay. Then once you have it, I make sure you're in the standard viewing window. So see, I'm not. So I'm going to just do zoom standard to get the standard viewing window to get the basic graph. Okay? So everybody okay to that point? Anyone having any issues with the calculator? Please let me know. Okay, so if we look at the question on the practice 3, is where is that polynomial greater than or equal to 3? Or greater than or equal to 0. Okay, so when we graph it, what we want is the part that's above the x-axis. Okay, so this little bit and that little bit is the answer. So what we need to do is find those zeros. Okay, so now you're going to need all 3 of those. So now let me remind you how to do that. Well, I'll find the first one for you. Well, actually, look, it's at these intercepts here. When if it's factored, the zeros, the x-intercepts are going to be at x equals -3, -1, and 2. Okay, so let's put those in. So this is at -3, -1, +2 are the intercepts. Okay, so then now interpret the answer. Oh, now, by the way, if you can't see it from the factored version, like let's say it's all multiplied out, then you can get those by second calc 0. Okay, get the zeros. All right, but now, so we have those. The highlighted part is the answer. Okay, so now how do we write that? How do we write the final answer, the values for x? What part of the graph is highlighted?
Would it be -3 to infinity?
From -3 to infinity, that would be if everything was highlighted. See this little part here between -1 and 2 is not highlighted.
Okay,
So that would make your answer incorrect.
Okay.
Wait,
I was taking it for everything above 0, so I get it. But I think Jill might have it.
Yeah, we want the x values. That's where the graph is highlighted. Okay, all right, go ahead.
Wouldn't it be -3 to -1 and then like union or whatever and then 2 to infinity?
That's exactly it. That's exactly it. So -3 to -1, union or whatever, 2 to infinity. And the symbol for union or whatever is the U. Okay? Now, could someone tell me why in my answer at these points I have a bracket instead of parentheses?
Because a bracket indicates that it includes whatever is inside.
Okay,
So-
and why do I want to include those numbers?
Because it's or equal to.
Yes,
It's-
that's it. Because it's or equal to, okay? Because it at those exact points is where the function is equal to 0. So if it just had greater than, then it would not include the points themselves, and so you would have parentheses at each of those. All right, beautiful, beautiful. All right, so any questions? So that's kind of how you do it on the calculator. The hardest ones is when you have to do second calc 0 to find those zeros, but it pretty much is just interpreting the graph. Okay. All right. Very, very good. All right. So now I'm going to show you how to do it without the graph. Okay. Now, the reason why I'm going through this is this skill is extremely important in calculus. This is what we're doing right now in calculus, in fact. Okay? So to solve, not graph, a polynomial inequality, you use what's called the sign test method. Okay? So first you find the zeros. Second, you graph the zeros or x-intercepts on a number line. Okay, so not the xy plane, just the number line. Okay, then third, you use a test point to determine positive or negative for each interval. And then the fourth step is to interpret the solution. All right, anybody need any more time on that? Okay. All right, so I want you to just watch this. Don't start on the practice problem because my feeling is a lot of you have never done this before, okay? So just watch this example. All right, so here, this polynomial is already factored. So the zeros are when you set each factor equal to 0. So the zeros here are going to be -3, -1, and +2. All right? So then you put each of those on a number line. Okay? So here's your number line, and I'm going to put -3, -1, and 2 on the number line. Okay? And so I put a 0 above here because this is what the function is. Okay, this is the polynomial. What the function is 0 at each of those points. Okay, so where the hearts are is where I'm going to try to determine if the polynomial is positive or negative in that interval. Okay, and whatever it is at one point in the interval, it's that everywhere in the interval. Okay, so you just pick a number. Let's say to the left of -3, okay? I'm going to pick -10 because that's an easy one to plug in. And so into the original function, I'm going to plug in -10. Now, I don't care what the answer is. All I care about is it positive or negative, okay? So when I plug in a -10, I'm going to get negative here, negative here, and negative here. So negative times a negative times a negative is negative. Okay? Now I pick a number between -3 and -1. Let's say -2. All right? So -2 plus 3, oh, that's positive. -2 plus 1 is negative. -2 minus 2 is negative. So positive times negative is positive. All right, now we pick a number between -1 and 2. Now, wherever 0 lies, I always like to pick 0. So I'm going to plug in 0 here. So 0 plus 3, positive. 0 plus 1, positive. 0 minus 2, negative. So positive times a negative is negative. All right, now you might say, well, does it alternate every time? And the answer is a little complicated, but no, it doesn't alternate every time. It alternates most times, but if you ever have a repeated factor that occurs with an even multiple, anyway, it's a little complicated, but you have to check. Okay? So you plug in a number bigger than 2, let's say 10. So 10 plus 3, positive, positive, positive. So that's positive. Okay? So that's the sign chart. Now you don't have to do the little hearts or whatever. Just do the pluses and minuses. Okay? All right, now, the last thing we do is interpret the answer. So the question says, where is this less than 0? So I want where the minuses are, where it's negative, okay? And it's not including 0, so I'm not going to include the point here, like -3. I just want this region right here. So that region right there is from -infinity to -3. And then union, and then this little region right here from -1 to 2. Okay? Now, if it were or equal to, then I would put brackets here. But it's not, so I don't. So that's my answer. Okay? All right, so I'm going to leave this example up, and I want you to try practice 3B, please. All right, Jay, when you've got it.
Can I have some help with this? I'm not getting it.
Sure. Okay, so did you graph 2, -5, and 4 on the number line?
Yes.
Okay.
That part's easy, but then it's like
Okay.
it gets weird.
Okay. All right. So now, okay, so the sign chart, that's the part that's messing you up?
Mm-hmm.
Okay.
Yes.
So you pick a number to the left of -5. Okay, so give me a number less than -5.
-6.
-6. Okay, so if we plug the -6 into this factor, -6 minus 2, is that going to be positive or negative?
It's going to be negative.
And -6 plus 5?
Still negative.
-6 minus 4?
Still negative.
Okay, so a negative times a negative times a negative is
It's going to be a negative, right?
negative. So then you put a little minus right there.
Okay.
Okay? All right, so now you're going to pick a number between -5 and 2.
0.
Okay? So 0 minus 2, positive or negative?
Negative.
0 plus 5?
Positive.
0 minus 4.
Negative.
So a negative times a positive times a negative.
No, that's negative, right?
Well, a negative times a positive would be negative,
Yeah.
but then
Oh,
times
yeah,
another
okay.
negative
Yeah, positive.
will make it positive. All right? Now pick a number between 2 and 4.
3.
3. So 3 minus 2.
Positive.
3 plus 5.
Positive.
3 minus 4.
Negative.
So a positive times a negative.
It's gonna be a negative.
It's going to be negative. All right, last one. Number bigger than 4.
5.
5. 5 minus 2.
3. So that's positive.
5 plus 5.
Positive.
5 minus 4.
Is it negative? No. It's positive. Sorry.
It's all right, it's all right.
Yeah.
And then a positive times a positive times a positive is
Gonna be a positive.
positive. Are you positive? Okay, so that's the sign chart. So
Okay.
now you interpret the final answer. So you look at the original problem. We want to know where is it less than or equal to 0. So we're going to include the points as well. All right, so where it's less than, that's negative. That's less than 0. Okay, so what region would this be?
I don't see what you're saying. I don't.
So the answer is going to be from the arrowhead all the way to this point because it's negative in that region. So
Okay.
it's less than 0. So how would I say that as an interval? That region. This part of the number line here that's shaded.
Huh?
Okay,
Oh,
so,
negative infinity, right?
so from negative infinity to what?
To -5.
To negative 5. Okay? All right, and then let's see, this is plus. So then this region also is less than 0, so I want that. So what would this part be right here?
From -2 to -4.
Yeah, except it's positive 2.
Positive.
You can't hardly see it because of that arrow.
Yeah.
So it's from positive 2 to positive 4.
Okay.
Okay, now, but now let's see, is it or equal to? Yeah, it's or equal to. So I need to include those points.
Mm-hmm.
So the final answer would be from negative infinity to -5, and you use the bracket to include the 5, union 2 to 4. And you have brackets on both of those because it's or equal to 0.
Okay.
Okay?
Yep. Thank you.
You bet. You bet. I appreciate you asking for help because that's really the best way to understand. All right. Any other questions? All right. Okay, let's see. No, we're finding zeros. Let's see, did we? Yeah, we're not doing that. We did that. Okay, so finding zeros of polynomials. To find a 0 on the calculator, remember it's second calc 0. So when you're finding these, if it's not all factored and easy to find, you still have to find them. You still have to put them on the number line. It's just you might have to find them with second calc 0 to do it. Okay? So like for this one, if I want to find the zeros of this, and see it doesn't factor. See, if it factors, you can factor it, set each factor equals 0 and solve it. But if it doesn't factor, then you graph it and then do second calc 0. So remember, you do left bound on the left, right bound on the right, and then press enter. And so when you're writing down the zeros, it's the x values, and you carry it out to 3 decimals. So you would write negative 5.193 and 0.193. Okay, if rounded up there. Okay, so go ahead and do practice 4. So that's not going to factor. So graph it, just kind of do an approximate graph on there, and then find those zeros where it crosses the x-axis. And I do want you to graph those accurately. All right, so Taylor, when you've got it.
Okay, wait, is it 1.162 and negative 5.162?
Negative 5.162 and 1.162. Nice job. Great work. Any questions? Anyone need me to go through that? All right, perfect. Okay, so that's it for 4.1. Any questions on that? Okay, so then what we're going to do now is go on to 4.2. Oh, let's see, I need to. Okay, so 4.2 is on polynomial division. Now, I'm pretty sure you've all had this before in Algebra 2. You have polynomial division, synthetic division. I'm not sure if you do constructing polynomials with given zeros, but that's probably the easiest part of it. Okay, so, but the thing about polynomial division is you usually you need a lot of practice with it. And so I'm just going to kind of go back to the basics of polynomial division, and then kind of assuming that you haven't had it, but I know you have had it, and we'll just kind of review the big ideas of it. All right, so it kind of all starts with, you got to remember the division algorithm. So how do you do long division? If you had 603 divided by 9, is that different than 63 divided by 9? Well, absolutely. Now you might say, well, the difference there is the 0. And I would tell some students, if I'm teaching, long division back in 5th grade or whenever you learn that, is I say, well, is 0 doesn't have any value. So how is it that this gives you a different answer than this? And of course the answer is that 0 does have an important value here. What is it?
It's 10.
Yeah, it's the 10. It's the placeholder. And so placeholders are extremely important when you're doing division. Same thing is true when we do polynomial division. We're going to need placeholders. Okay? So that's the first big idea. The second idea is just to kind of remember, when we're doing division, you say, okay, 9 won't go into 6, but it'll go into 60. And then you say how many times, and then you multiply, subtract, bring down the next number, and then you do it again. And if you end up with a 0, then that means that the 9 divided in evenly. And you might have even learned, maybe, that 9 is a factor of 603 if it divides evenly with no remainder. Now, when you do the division algorithm, if you get a number here that's smaller than your divisor, then this is the remainder. And you probably first started your remainder putting like a big R1 or whatever. And then as you got a little more sophisticated, you wrote your remainder as a fraction or a decimal. And so here, this would be 67, and then the remainder is of 1, you write over the divisor, so 1/9 would be kind of how you do that. That's more akin to how we're going to do it in polynomial division. We're going to write the remainder over the divisor. Okay? All right, so when dividing a polynomial f of x by another polynomial d of x, if the remainder r of x equals 0, then d of x divides evenly into f of x, and d of x is a factor of f of x. So when we get to factoring these huge polynomials, if it divides in evenly with no remainder, we're going to be able to factor polynomials that you've never been able to factor before. Okay? All right? So that's how we're going to do it with polynomial division. All right. So let's go through this one together. Okay? So this is practice 1. So divide 3x squared plus 19x plus 28 by x plus 4. All right, so the first polynomial, that's your dividend. So you write that under the fraction bar. What you're dividing by, that's called your divisor. And so the x plus 4 goes on the outside. Okay? Can anyone tell me what the answer that we get, what's that called? The answer to a division problem.
Say again.
Quotient.
It's quotient. The answer to a division problem is called a quotient. Good job. So we're going to find the quotient, or the answer here. All right, now, just like with the division, we just look at it's kind of like looking at the first numbers. We're going to look at just the first terms of both the dividend and the divisor. And you say, okay, what times x is 3x squared? And so what's that? What times x would give you 3x squared?
3x.
3x. So you write that up on top, is that's going to be part of your answer, part of your quotient. So you write your 3x. Now, if you think back to the division algorithm, the next step would be to multiply. The difference is that you're not multiplying by one term. You're multiplying by 2 or more terms in your divisor. So you're going to multiply the 3x by the x and get the 3x squared, but you're also going to multiply 3x by the 4 and get 12x. Okay? All right, so 3x times x is 3x squared. 3x times 4 is 12x. And so you line that up. All right, any questions thus far? Okay, now, this part is the tricky part. So you need to be focused here. All right, in the regular division algorithm, at this step, you subtract. The problem with polynomial division is you have more than one term. Sometimes they're positive, sometimes they're negative. So instead of saying subtract at this point, what I say is change the signs. Okay? Now, I also would recommend on this step that you get out another color pen or a pencil or a highlighter or a marker. Use a crayon. I don't care. Pen and a pencil. But it's hard if at this step, because you're changing the signs, if you don't use another color, it's hard to go back later and check your work. Okay? So you're going to just change this to a negative, change this to a negative. So instead of subtracting necessarily, I say change the signs, and I do that. Boom, boom, right there. All right, now, 3x squared minus 3x squared is 0. So the first term should always drop out. Okay? The second term's 19x plus a negative 12x, or 19x minus 12x, is going to be 7x. And then you bring down the next term, just like with the division algorithm. Okay? Now you go through it again, and you look at the leading terms again, and you say, what times x is 7x? So that would just be 7. So you put the plus 7 right up here. All right, so then you're going to multiply through. 7 times x is 7x. 7 times 4 is 28. Change the signs. Boom, boom. This goes to 0. This goes to 0. So that means that x plus 4 is a factor. It divided in evenly. As a matter of fact, if we were going to factor this, see, we don't need to use the double bubble method. We don't need to use the AC method. Is that we actually just factored it because we got a remainder of 0. Okay? Yep, that's good. That's good. So, any questions on that? All right. Let's go to the next one. Okay, before applying the division algorithm, you should do the following 2 things. Okay? Number 1, you need to make sure that your polynomials are in descending order. And number 2, you need to add placeholders where necessary. Okay? So just like that 0 changes if you have a 0 in the tens place, you have to have that 0 in there or you'll get the wrong answer. Same idea here. Okay? All right. So when you set this up, okay, see both of these polynomials are already in descending order. So you don't have to worry about that. But what don't you have? Or what do you need to add to that first polynomial?
0x.
0x. So when you're setting up the problem, okay, the divisor is still x minus 3, but the dividend, you want to write that is x cubed minus 2x squared plus 0x minus 9. If you don't do that, you're going to often have problems, okay? So we're added a placeholder. Does everyone understand why I need that? Any questions on why I need to put in the 0x?
I do not understand why.
Okay, see, you have an x cubed, an x squared, and see then the next place would be x before the constant. There is no x there.
Okay.
And so you have to plug in a 0x. So let's say if you didn't have this term either, then you would have to plug in plus 0x squared. And you'd have to have 2 placeholders. Because if you start with x cubed, you have to have every term all the way down to a constant.
Oh.
Okay? So that's what I mean by the placeholders. You have to put those in. Okay?
All right. Thank you.
You bet. Thanks for the question. Okay, so see if you can finish this problem now. We've got it set up for you.
Mr. Strong, I have a question.
Yep.
Why do they say bring down like the next one instead of just writing out the entire thing each time, each step?
You could, but see, that would give you extra terms that you don't subtract off, and so it would, it's kind of like, all right, going back to, let's go back to the original. See, when you're dividing here, and you do 6 times 9 is 54. See, you only have one digit here. If you had another digit, see, it might be confusing to divide into the other digit. See, it's easier to say what times 9 is 63 versus if I had like a 4 there. And you know what I'm saying? It would be harder. You're making it harder than you need to.
Oh, okay. Yeah, that makes sense. Thanks.
Yeah. All right, so Cyrus, when you've got it, let us know.
Can you go through it for me, please?
Sure. So you look at the leading terms. So Zyrus, you tell me what times x gives you x cubed?
X squared.
X squared. So you write x squared up here. And so now you're going to multiply through. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. Change your signs. Boom, boom. So this cancels. And then you have negative 2x squared plus 3x squared is positive 1x squared.
Yeah.
Bring down the 0x. Okay, now you do the same thing. Look at the leading term. What times x is x squared?
X.
X. So you multiply and you get x squared minus 3x. Change the signs. Boom, boom. This cancels. This 0x plus 3x is 3x. Bring down the negative 9. So now you go through it again. What times x give you 3x?
3.
3. So you multiply through and you get 3x minus 9. Change the signs. Boom, boom. Everything cancels, so it divides in evenly. So that is your answer. X squared plus x plus 3.
All right. Thank you.
You bet. Any questions?
I know I timed
Yeah.
That makes sense.
Stated that one.
Okay.
I could have
All right. Could you guys mute there in Holbrook? Okay. So the answer to a long division problem is written as, so you have your answer, the quotient. So that's some polynomial like we just had. Plus, and then you write your remainder over the divisor. So if your remainder is just 3, then it's 3 over x minus 2 or whatever your divisor is. That's what your answer will look like. Okay? Now, I'm going to jump ahead and give you the next blank as well on this front part. Is that long division also works on polynomials with complex coefficients. So you just kind of do it the same way. So I'm going to see if you can figure that out. So what I would like you to do is before class on Thursday, I would like you to do those 2 practice problems, practice 2B and practice 2C. But we'll go over those, and if you got stuck, that's okay. I just want you to try it. But we'll start class on Thursday going through those 2 practice problems. Okay? All right? So let's just set up the first one. Okay, we've got 1 minute here. Okay, so for this one, is there anything we need to worry about? Is there any tricks on this one?
It's well, you need a placeholder and you're dividing by a trinomial.
Yes. So you're dividing by a trinomial and you need a placeholder of 0x squared. So when you set it up, that's going to be your dividend, and then your divisor is going to be a trinomial. So you're going to have all three terms each time. Okay? All right. So we'll pick it up from there. So remember the quizzes tomorrow? 3 quizzes.